This is the final piece of the significant figures puzzle. If you've been watching the lectures leading up to this one, you pretty much have everything you need. But there's one more thing that I want to clarify. It's that I've been teaching you how to count the amount of significant digits in every number and then figure out how we round our answer. And now I'm going to tell you that sometimes we don't count the number of significant digits that are in a number because that number doesn't help us round our number at the end to get to the correct answer. This is one of those things in chemistry that really starts to frustrate people, and really in physics, science, all of them, is that there's always exceptions to all the rules. So let's discuss it right now. What should you do about these things called non-measured numbers or exact numbers? The first one are non-measured numbers. And to define this, these are any numbers that are not measured in any portions or decimals. For example, a dozen eggs, right? A dozen eggs, we all know is 12 eggs. It's not 12.1 eggs. It's not 12.01 eggs. There'll never be a decimal associated with it. It's 12. If it's always 12, then it's exactly 12. So it's not a measured value. And significant digits only deals with measured values, things we've actually measured with a ruler or measured on a balance or a graduated cylinder. And we're not measuring that. It's just 12 objects. Another way to look at this are 500 people. We'll never have 500.1 people, 500.01 people. It's not a measured value. It's counting. We're just saying we have 500 of these objects, right? We haven't measured anything with those objects. So if we had 500 people in an equation, we wouldn't count the significant digits in that because it's not measured. 5 pennies, same thing. If we have 5 pennies, we literally have 1, 2, 3, 4, 5 pennies, or 4 pennies, or 3 pennies, or 2. We never have 2.5 pennies. So these are sometimes obscure things that we need to think about as we're working through problems and dealing with significant figures. I'm going to show you some examples coming up and with all of these, but let's start with the pennies that we just talked about. If we have a problem that says calculate the mass of 5 pennies by multiplying the mass of 1 penny times 5, this equals 12.4, really it's grams because of the objects that are pennies. Now let's think about the rules that we've learned with significant digits. This is a multiplication problem. Multiplication, we need to look at all parts of the problem and decide what we should round our answer to. So we come over here, there are 1, 2, 3 significant digits over here. And if we're not careful, we would look at this number and say there's one significant digit right here, which means I would need to round my answer to one significant digit. I'm going to write it over here. That would mean I'd have to round my answer to 10 grams because that only has one significant digit. That's not right because it's not right because that's not what we're saying. This is not a measured number. That's never going to be 5.1 or 5.6 or 5. It's 5 pennies. So because it's not a measured number, it doesn't limit our significant digits. We only look at the measured one, which there's a measured value. There's our measured value. This is just counting out 5 pennies, which means we can have 3 significant digits. And indeed, we have 1, 2, 3 significant digits in our answer. So this is one of the ways you might encounter something with non-measured numbers and need to deal with them and make sure you're not counting them as significant digits. The second thing we need to understand are exact numbers. Exact numbers have an infinite number of significant digits. They're exact. So they're like exact. And we're trying to look at measured numbers that aren't exact, where they've been estimated based off of however they have been measured. So if we look at an example of that, something like 100 centimeters in 1 meter, that's an exact measurement. That's an exact conversion. There are exactly 100, and to be exact about this, there are 100.00000 repeating to infinity centimeters equals 1.00000 to infinity meters. In fact, I'm going to turn this into something called a conversion factor. So I'm going to take our 100 centimeters and I'm going to put that over 1 meter, because that's what we're saying here. There are 100 centimeters per 1 meter, right? Now, likewise, that's 1 meter per 100 centimeters. Those mean the same thing. Now, quick side note, if you have a math teacher, so if you were to tell them 100 over 1 is equal to 1 over 100, they would come find me on YouTube and drag me out, and I don't know what would happen to me, because they would say this is 100%, because it's not true. Because these are numbers, right? These are objects. These are things. These are measurements. These are conversions. There are 100 centimeters in 1 meter. There are 1 meter is 100. There's a relationship between them, and that relationship is exact. And if it's exact, they have an infinite number of significant digits, which means if we run into conversion factors like this in a problem, here's a little hint, the very next videos coming up are going to teach you how to do dimensional analysis, and every problem is going to have stuff like this in it. And if we have metric conversions like this, are we going to count the significant digits? No, we won't. And another metric conversion, 1,000 grams and 1 kilogram, is exact, so we would never count the significant digits in that problem. Now let's look. Going back to our penny, see if I can drive this home with a very, very simple mass problem. What is the mass of 1 penny converted into kilograms? Well, let's start here. We've got the mass, which is 2.48 grams. Now, in dimensional analysis, so the math that I'm about to do, if it doesn't make sense, wait till the next videos. Go to the next ones, which are dimensional analysis, which I will argue is the most important skill that you can learn in introductory chemistry, because it's the basis of all the math that we're going to do for conversions. So 2.4 grams, I'm trying to convert that. I've got what's called a conversion factor waiting for me right here. And I need to turn that into kilograms. Okay, well, I'm in grams. I want to be in kilograms. So I'm going to put grams down here, because I know if I have something on the opposite side of the line, some people don't like this, so they like to see it over 1, and that makes a little more sense. If you like it over 1, put it over 1. Doesn't matter to me. And then there is a conversion to take grams into kilograms. It's right here, right? 1,000 grams is 1 kilogram, which means these two things are going to cancel. I'm only left with kilograms right here, which is what I want my answer in. So this is perfect. This, in math terms, becomes 2.4 times 1 divided by 1,000. So this is 0.0024 kilograms. The rules that we've learned about for significant digits, this is a multiplication and division problem. So we would look at this 2.4. Now let me take it back to the way it was before I put it over 1, just to make some people feel better. There we go. So we've got the 2.4, cleaning up, 2.4 times 1 divided by 1,000. Now this number has 2 significant digits in it. Let's look at these two. You could very easily try to argue, well, this only has 1 significant digit, and down here, this only has 1 significant digit, because these are trailing zeros, and trailing zeros are not significant digits unless there's a decimal somewhere. So 1 significant digit here, 1 significant digit here, and people would say, well, then I should round my answer to 1 significant digit. No, no, no. Because this right here, what we just talked about, this is called what? This is an exact number. It is exactly 1.00000 to infinity per 1,000.00 to infinity. So the significant digits in both of these is infinite. Do we care about the ones that have a whole bunch of significant digits? No. We care about the ones that have fewer, because that tells us what to do with our answer. This has 2 significant digits, so I need to round mine to 2 significant digits. Turns out, there's 1, there's 1. These are leading zeros, which are never significant, which means my final answer here is 0.0024 kilograms. And that's it. That's 2 important exceptions that you need to understand for significant digits when you're trying to round your answer. And the best way to get good at doing significant digits and dealing with these exceptions and learning how to is practice, practice, practice. Practice makes perfect. And then it'll become second nature, and you won't have to worry about what should I be rounding this to? You'll just be able to do it no problem. So the next thing that we're gonna cover, which it says right on the screen in front of you, the most important math skill you can learn in chemistry, which is dimensional analysis, is coming up next. We're going to take everything we've learned up to this point and we're going to start to apply it to the math that we need to be able to do in chemistry. So thank you for watching. There's stuff popping up on the screen. Feel free to click it, subscribe down there. Look in the description. There are other videos. There's links to that. There's other things on the screen. And go to Beals Science, bealsscience.com. All the different things. And I want to remind you, keep on learning.